Okay, so today we are doing stretches and shrinks part B. And in my class, we did a bunch of top 20 stuff at the beginning of the hour. So we need to kind of get right to our worksheet. I'm going to do some of these practice problems with you as a way of showing you how these harder stretches and shrinks will work. All right, first thing I'm going to do is rewrite this. Y equals square root of something x. I need somebody to help me with this. X over 2 would be smarter to write differently. Who's got it? Yes, sir. Yes, 1/2 x. 1/2 times x. Why is that smarter? Because it shows me that it's a stretch or a shrink on the inside. Now, you got to think this through. This catches people all the time. Is it horizontal or vertical, first of all? Horizontal. That part, most of you guys have got this down, that it's high-vo, horizontal on the inside. So that's a horizontal. Now, it seems like it's a shrink because it's half. So it's not a shrink because it's on the inside. We don't trust it. Horizontal what? Stretch. Factor 2. And a stretch goes with a whole number like 2 or 3 or 4. Something bigger than 1. Horizontal stretch, factor of 2. All right, now, if you were to graph the parent one, it's square root of x. You get that the square root of x is what we started with? And that's this one. 1, 1, and 4, 2, and 9, 3. I hope you know how to do square roots to get those points. There's my square root function in the first place. Now, think about this. We want to make it twice as wide. It's stretching it. So, I'm going to make my new points in blue. How wide is 0, 0? It isn't wide at all. It has no width. To get to this point, I have a distance of 1. So I'm making it twice as wide. So I'm moving it over there. The third point, which is right here, it's not there anymore. It's got to be twice as wide. So instead of, how wide was it now? From here to there. From here to here, it's how wide? 4, so I got to go to 8. And that brings me out to here. What I just did there is took this black point that was at 4, 2, and I moved it over twice as wide. And this blue point here came from this black point here. Okay, got twice as wide. Now I'm going to connect it all with a green line and connect my blue dots. And it got stretched wider. You got to think of it this way. If this black one's the parent one, and you grabbed it like right here with your hand, and you pulled this way, you get how it would stretch, like if it was made of rubber, it would stretch to be like that green one. And now your hand would be like out here on the green one. All right, so that was a horizontal stretch. Now, some people are going to say, but Mr. Server, you told us the XY chart was the way to go. It is. It would be smart. I've said that you should do both. If your life depended on it and you made the wrong graph, you're going to be stuck on Mars for the rest of your life because you screwed up the math. Anybody watch The Martian over the weekend? None of you? None of you. It was like almost the biggest October release of a movie ever. How dare you not see that? Anyway, I didn't either, but I want to. I figured somebody out of 30 would have seen it. Okay, so my XY chart, I stick in any number I want, but I should pick strategically. Do you get, like, if I put in x is 3, it's going to be a pain in the butt to do square root of 1/2 times 3? Yeah, so I should probably pick something a little easier, like 1/2 times, what would x be? What's a nice number for x? 0 works great. Because if I put in a 0 here, 1/2 of 0 is 0. Square root of 0 is 0. 0, 0 is on my graph. Yay! Next one I can check. Remember, I said you just check a couple, and if they both work, then you know you're probably doing it right. 2. I put in a 2 here. I put in a 2 here. 1/2 times 2 is 1. Square root of 1 is 1. 2 comma 1 should be on the graph. And look at that. It's this red dot, or this blue dot right there. 2 comma 1, and yes, I did the first couple points right. I probably am doing it right. Okay, so reminder, XY charts are a great way to check and see if you're doing it right. Okay, this next one's a V shape. That's stretched 3 times taller and it's moved over to the right 1. I suggested that it would be smart to take your parent points and do the inside changes first. Do you remember that? So which way should I move this? Right or left? Right 1. So I'm going to move everything right 1. And then I'm going to take each point and make it go 3 times up. Yep. So its height, which this one has no height, so it doesn't move. This one's height is 1, so this blue dot is going to move up to twice as high. There. Oh, 3 times taller. You're right. It's not 3. It's 3 times taller than it was. There we go. Thank you. Good catch. Next point. I'm going to take this dot right there and move it and make it 3 times as tall. 1, 2 spots up. Now it's up 3 instead of being up 1. And now it's going to still make a parabola, but the thing is going to get quite a bit stretched upwards. So this had a height of 2, so I'm going to triple it. Up 6. And there'll be another spot commensurate to that over here. There we go. And the old V compared to the new V is quite a bit stretched. Think of it like you grabbed it with your little hands right here and right there, and you pulled them up. Then the black one would turn into the blue one. Now, what if you weren't sure you were right? XY chart. Pick any number I want, I stick it in here. 0 is a nice number. 0 minus 1 is negative 1. Absolute value of that is 1. 1 times 3 is 3. 0, 3 better be on my graph. Look at that. There it is. 0, 3. It's on my graph. Cool. I'm doing it right. So my graph is the blue one. This is my finished graph. The black one was the parent graph I started with. Actually, I started and then I moved the black one over 1 spot because of that -1 right there. Okay, the next one's got a weird twist to it that we should talk about. Do you get that there's stuff over there by the Y? Yeah. So it's really not too complicated. How do I get that stuff over onto the right side? Should I start with multiplying or adding? We're on the outside, we're solving an equation. To fix divide by 3, I times by 3. Times by 3. But if you times by 3, don't you normally put that in front? Yep. If I could squeeze it in there, I would. And then after I did that, I'd want to get rid of the +6. How do I do that? Not add, subtract 6. Subtract 6. Now I'm going to rewrite it. Y equals 3, parentheses, x minus 2, squared, minus 6. Oh, I'm supposed to describe, too, what transformations I did. Last time, I went right 1 and vertical stretch factor 3. Sorry about that. I forgot to describe the transformations. So in this one, if I have 1, 2, 3 steps, what's step 1? Say it if you know it. Right 2, thank you. And what's step 2? Nope, don't do the -6, thanks for trying. What's before that? The 3. And is that 3 a vertical or horizontal thing? Vertical stretch factor 3. And then the last thing is the 6. Which way am I moving the 6? Down 6. Good. All right, so now if I knew what the parabola was in the first place, I would graph it, and I do, so I will. There we go. There's my parent points for the parabola. Now I say you should start on the inside and move it right 2. 1, 2 to the right. Then I go to the outside, and I do my stretch next, and I make it 3 times taller than it was. This point goes up to 3 times taller than it was. 3 times taller. I can't get up to 12 on this one, but if I could, it would be about there. So there, here's my new parabola, really been stretched. And then where do I have to move it? Down 6. That's me stretching it 3 times taller. The blue one is the vertical stretch. It's supposed to be a curve at the bottom, not a pointy bit. Okay, and the last thing is move it down 6. So then I can take every point and move it down 6. So I go down 1, 2, 3, 4, 5. That. Oh, wait, they've been stretched. Each point down 6. There we go. Move this point down 6. There we go. Now, XY chart could save the day. Let me make sure I'm doing it right. Let's say I put in a 2. I stick in a 2 right here. 2 minus 2 is 0. 0 squared is 0. 3 times 0 is 0. Minus 6. 2 comma negative 6. Look at that. 2 comma negative 6. Right there, right where I knew it should be. Could you just do it with the XY chart right from the beginning? Yeah. And some of you guys will choose that option. Instead of graphing the parent and then moving it and stretching it, you can use the XY chart as long as you're good at plugging numbers in. So let's try plugging in a 3 right there. 3 minus 2 is 1. 1 squared is 1. 1 times 3 is 3. 3 minus 6, negative 3. 3 comma negative 3. Look at that. It hit this spot right there, just like we thought it should. So when I got my first couple points matching up, it's probably right. I just have to finish where these last couple points is on the red one, and then I've got that one done. All right, I'm helping you get started with this because that covers most of the things that you'd have to do with those first 3 problems. If you can do those type skills, the rest of it will be fine. Now I want to leave that up for you to look at if you're not quite done with that. So I'm going to use my snipping tool, take a picture of it. That way I can save it in case anybody wants to see it again. Oh, this got unplugged. That's why I can't turn this thing on. And I'll drag it over to my second screen. There we go. And then I can clear this board off. And that writing will still be on my other screen. How are you going to start D as in donkey? How do you start it? Times by 2. You times by 2 here, you times by 2 there. And it's y equals 2, absolute value x over 4. Ooh, it'd be even smarter if I could write that instead of x over 4 to be a what? 1/4 x. Very good. Then, if you want to, you can make an XY chart and do it that way. If you want to, you can make the parent points, the V shape, and then do a stretch 4 times bigger. Seems like it's 1/4 as big. Remember, can't trust that. 4 times wider, 2 times taller. So you take every point and move it 4 times wider. So like this dot here has to go 4 times wider, and then 2 times taller. There we go. Do that to every point and you'll have it. Or you can use your XY chart, or even better, use both. All right. I think that's given you the idea how this thing works. Wasn't a normal lesson today, but I'm hoping that it accomplishes what we need to. I feel like it's a little bit long. I'm going to have you skip E and F, and then you can skip this one, and then you can skip E and F on this next set of problems. Holy smokes, there we go. That's it finally. E and F, wherever they occur, on this little unnumbered problem right here. This parabola was a skip. All right, that's all I got for you for today.